Okay, the solutions to last year's task 1. Okay, cos theta, well cos we know is to be adjacent over hypotenuse, so the adjacent has to be B and the hypotenuse is C. Alright, tan theta, now you can either sub in each one of those answers into the tan theta to get close to 0.85, but much better, whenever you need to find an angle, you need to do the opposite of tan, which is second function tan, or tan to the minus 1, 0.85. And we get 40.364645. Second function DMS gets you 40 degrees, 21 minutes and 52 seconds, which is close to 22 minutes. Okay, 3. Find x, so we have the angle, and we have the adjacent, and the opposite, so that's tan. So tan 23.5 degrees equals opposite over adjacent. Now x is on the bottom, so whenever x is on the bottom, let's switch. So we get x equals 14.7 divided by tan 23.5. We get 33.807. We want obviously one decimal place, which is obviously B. Alright, the largest angle in the triangle, the largest angle is opposite the largest side, so 7 is the largest side, so theta is our largest angle. Now we have 3 sides and 1 angle, that is the cosine rule. So using your formula sheet, cos theta is 6 squared plus 5 squared minus 7 squared. The minus 7 is very important, divided by 2 times 6 times 5. Using brackets, if you've got the ABC calculator, we put that in and we get cos theta is 0.2. Again, whenever we need to find theta, we do the second function of cos, and we get 78 degrees and 28 minutes, and that is obviously closest to 78. Okay, to find x, well, we have 2 sides and 2 angles, that is the sine rule, so x over sine 65 must equal 17 over sine 18. Now to get rid of divide by sine 65, to leave x by itself, we have to times by sine 65. And you'll see there that will be that question, that answer there. Okay, so question 6, we have an annulus. Now the formula sheet states that we have pi, bracket, large radius, which is 3.5 squared minus small radius, which is 2 squared, or individually, pi r squared minus pi r squared. So pi times 3.5 squared minus pi times 2.2 squared, and we get 25.918, which is 25.92, so which is B. Surface area of the closed hemisphere. So we have 4 pi r squared for a full hemisphere. So half is 2 pi r squared, but it's closed, so we also need to include the circle, another pi r squared. So it is 3 times pi times r squared, which will be 8.4 squared. And we get 665.012, which is obviously B. Okay, number 8. We have a trapezoidal prism. So we have a trapezium, that goes back 1.4. So we have volume is area times height. So area of the trapezium. So the trapezium is h on 2. Now the height of the trapezium is 0.8 on 2. The top plus the bottom, and we're going to times all that by the height of the whole prism, which is 1.4. And we get 4.256, which is B. Alright, we have a sector. Now, pi r squared, so pi times 7 squared is the whole circle. What's a part of the circle don't we have? We don't have 85 degrees, so that means we have 360 minus 85 is 275 out of the 360. And we get 117.59, which gets us 118. Now Tom measures a piece of fabric with a ruler only marked in centimetres, so therefore the precision is 1 centimetre. Therefore the absolute error is half that, so 0.5 centimetres. So therefore the length is either going to be minus that, so 60 minus 0.5 gets us 59.5, to the largest is 0.5 plus that, so we've got 60.5, and the width is going to be 90 plus or minus 0.5, so we have 89.5 as the smallest to 90.5. So obviously the area, the smallest area, will be that times that, which gets us 5325.25, and the largest area will get us that, which is 5475.25, which gets us C. Okay, we need to find the height of the taller building. Now to get that, we firstly need to find that length. So we call it x. We have the opposite and the adjacent. So we have tan 60 equals opposite over adjacent. How do you divide by 42? You times. So x will be 42 times by tan 60, and we get 72.746 meters. So therefore the height will be 135 plus the 72.7. We need it to the nearest meter, so that's actually 73, so we get 208 meters. So 12. We need to find G, so we use the sine rule because we have two sides and two angles, but they don't match. We need this angle in here, so triangle is 180, so 180 minus 43 minus 33 gets us 104, so this angle here is 104. So sine rule states G over sine 33 must equal 55 over sine 104. How do we get rid of sine 33 divided by? We times, and G will become 30.872. We want it to one decimal place, so 30.9. U, which is theta, so we have two angles, two sides, so the sine rule, but this time we're going to flip it. So sine theta over 32 equals sine 114 over 76. How do you divide by 32? So we are going to times by 32. So we get sine theta, put that all in your calculator, get you 0.38 ... To find theta by itself, we do the inverse, so sine to minus 1 of my answer, alpha answer if you need to. And we get 22 degrees to the nearest minute is 37 minutes. Alright, so show by calculation that the value of angle A is 45.54. Now, we're not going to use that, we're just going to get that answer at the end. So we have three sides and we're finding another angle, so the cosine rule. So cos A equals, alright, that needs to be at the end, so 58 squared plus 29 squared minus 43 squared, all over 2 times 58 times 29. Again, we're going to use brackets, and we get 0.70 dot dot dot. We only want to know A, so again, to get rid of cos, we do the second function of my answer, and we get 54.54 degrees as required. Now the area, it's not a right angle triangle, so we can't use half times base times height, so we have to use half times A times B times sine C. Now A and B are between, next to the angle, so 58 and 29 times sine 45.54, and we get 626 meters squared because we wanted it 2 decimal places. Alright, now the paddock is divided into two triangular paddocks by constructing a fence from, so B to AC. So I'm going to draw that again. So A is down here, B and C, so we are going to have a line that is right angle. Okay, so we know that this is 29 from A to B. We know BC is 43, and we know this is 58. Now, we want to know how many meters of fencing will construct BD, so D is down here now. We also know that this angle is 45.54. We need to know X, so we have opposite and hypotenuse, so we have sine. Sine 45.54 equals opposite over hypotenuse. How do we divide by 29? We times by 29. And you get 20.6984 meters, but it says to nearest centimetre, so your choice is either times this by 100, or because there's 100 centimetres in the metre, you need 2 decimal places because there's 2 zeros, so we need to stop it there, so we get 20.69, the 8 brings the 9 up to a 10, so 70 metres, or it will be 2070 centimetres. Alright, AOD, that angle there, well, we have a north line there, so it will be 360 minus 314 will get you this one, plus 60 will get you that, which will get you 106 degrees. Now AD, so we have non-right angle triangle, 3 sides and 1 angle. Now, we are obviously finding that side, so 3 sides, 1 angle is cosine rule. 101 squared plus 92 squared minus 2 times 1 times 92 times cos 106, and we get, always need to square root, and we get 154 meters because it's the nearest meter. Okay, angle COB. COB is 68 degrees. What is the bearing of C from O? So that's just simply what is that direction there. Now, if we know that is 152, it's just 68 on top of that, which is 220 degrees. It's only worth 1 mark, so it should be an easy question. Alright, Imran flies this plane to Conowindra on 200 kilometres on a bearing of 115. So, from Conowindra, he flies on a bearing of 115 degrees. He picks up Kevin, Drogheda, and flies him 255 on a bearing of 42 to Eastern Hills. So, from that, we have 42 degrees. Alright, complete the diagram, which we just did. Then show that the angular mark theta is 107. So, now norths are always co-interior or alternate or corresponding, so parallel lines. So, to get theta, we also need this one, and you'll see here we have a C angle which adds up to 180. So 180 minus 115 gets us 65 degrees. 65 plus the 42 already there gets us 107. Now the distance, we have cosine rule, so very similar to the other question. 200 squared plus 255 minus 2 times 200 times 255 times cos 107, which gets us 135,474.86. We only want x, so we square root, and we get 368.0691003. Now, to the nearest metre, but it's in kilometres. So again, you can either times this answer by 1,000 to put it in metres, or if you're going to leave it in kilometres, we need to do 3 decimal places because there are 3 zeros in 1,000. So we're going to stop there. The 1 does nothing, so obviously it is 368.069 kilometres. Now, what is the compass bearing of Drogheda from Eastern Hills? So it's only worth 1 mark, so it should be a pretty easy question. Now, so we have from East Hills, so therefore Drogheda, so we need to know this. Okay, so we can extend this line here, and what we said before with the compass rose, we can always get alternate or co-interior, and you'll see here we have a Z angle, so this here is 42 degrees, all the way to south is 180, so it's going to be 180 plus 42, which gets us 222 degrees on a true bearing. Alright, volume of a cone. It has a height of 120 and a radius of 75. So cone is 1/3 the area, which is pi r squared, times by the height, and we need it to the nearest cubic centimetres, so whole number, and its volume, so it's centimetres cubed. Okay, garden bed, semicircle, and right angle isosceles, so this is also 12.1. So we have triangle, half times base times height, plus we have the circle, which is pi times r squared, so it's going to be 6.0 0.05 squared, but it's only half a circle, so we're going to divide it by 2. 1 decimal point gets us 130.7 metres squared. Alright, find the volume, just 2 significant figures of this. It's a whole cut out, so the whole cube is 5 by 5 by 5, and we're going to take away the cylinder, which is pi r squared times height. Pi times, now the diameter is 2, so therefore the radius is 1 and the height is 5, and we get 109.29. We only want 2 significant figures, which stops there. The 9 rounds the 0 up to a 1, and we must replace it by a 0. Alright, the volume of a square pyramid. Now, square pyramid is a third times the area. Well, the area of a square is side times side, or side squared. You can use length times breadth if you like, times by the height, which is 6, and they say the answer is 62.72. Okay, so we need to isolate s squared. So to get rid of times by a third, we're going to divide by a third. To get rid of times by 6, we divide by 6, and we get s squared equals 31.36 square root, because we only want s, and we get 5.6 metres. Okay, 2 applications of Simpson's rule. So we know Simpson's rule is h over 3, so the distance between intervals. So we're going to cut this into 2, and the distance between each interval will be 3. So 3 over 3. The first measurement, 4, plus 4 times the second measurement, or the middle, 5, plus the last measurement, that's the first application, plus distance between, 3 over 3. First measurement, 5, plus 4 times the middle, 4, plus the last, which will be 0. That is 0. Put that all in a calculator, and we get 50 metres squared. Alright, Tony uses a syringe to measure 2.7 mils of medicine. Calculate the 1 decimal place the percentage error. Okay, so firstly, the precision. The lowest of that will be 0.1 mils. So the absolute error is half that, and we plus and minus. The percentage error is the absolute error over the measurement, and we're going to convert it to a percentage, and we get 1.9% to 1 decimal place. Alright, the wooden peg, using the given dimensions, calculate the entire surface area. Okay, now we have the lower cylinder and then also the upper cylinder. Now, with the lower cylinder, we have the bottom, which is a full circle, the top, which is a circle with a hole out of it. But if you take this circle here and actually include it, you'll just have two full circles there. So we're going to do the first one, first cylinder. So this is a full cylinder. On the formula sheet it says 2 pi r squared. So 2 times pi times 5 squared is the radius, plus 2 pi r h. So again 5 and times by 4. So that gives you the big cylinder. Now the small cylinder, so normally the small cylinder will be the same thing. 2 times pi times 1.5 squared plus 2 times pi times 1.5 times 30. But we don't need that bit because the two circles, well, one's obviously hidden and the top one we used as part of that big circle. So if we put that all in, we get 5.6, sorry, we get 565 centimetres squared. Okay, toy maker, well, he's got 150 of those, so we're going to do 150, and we need 2 coats. So we're going to use centimetres squared, and because it's in talking about metres squared, we're going to divide this, well, centimetres in a metre, 100, but because we're talking about centimetres squared, 100 squared, and we get 16.95 metres squared. Is it going to cover enough? No. We won't be able to do paint 1.95 metres squared. Now, if you didn't like part A, the way I explained it, the other way is obviously, okay, we have the bottom circle, which is pi times 5 squared, plus the top annulus, which is pi times 5 squared minus 1.5 squared, plus we have the round bit, which is 2 times pi times r times height, plus we have the top circle, which is pi times 1.5 squared, plus we have the round bit, which is 2 times pi